Today we will talk about combination of two vectors, that is how to find the sum of two vectors. You all know how to find sum of two numbers. For example, I give you A is equal to 10 units and B is equal to 35 units. Then A plus B is simply 10 plus 35, which makes it 45. You all know this. Can we do the same thing in vectors? So let's say OX is some 10 units, OY is some 11 units. Now, can I combine OX and OY in vectors? Answer is yes, we can. So, do I get OX plus OY is equal to 10 plus 11? Do I get this? Is the question. Answer is not necessarily. You may get 10 plus 11 or you may not get 10 plus 11. You may get some other answer. Why? That's the interesting part in vectors. In vectors, we have the values of the vectors, which are 10 units and 11 units. At the same time, they have directions, x direction and y direction. So if these are two vectors which are mutually perpendicular to each other, then how to combine them is we have a method to combine them. Let's see that. How do we do? So let me erase this portion here. And I want to combine the two vectors in such a manner that I get the result of the two vectors, that is sum of the two vectors. So the method to combine them is, if I know the angle between them, which is, let's say theta here, it's 90, we know that, but let's assume it's theta. Then let me call this as OX and this as OY value. Then the resultant is given as R equals square root of OX square plus OY square plus 2 times OX times OY times cosine of the angle between them. This gives you the sum of the two vectors value. How did I get that one? Is different story. I will prove that. How did I get that? But at present, let's assume that that's how the value is given. Now, we have one more peculiarity here. That is, okay, I added them, I don't get this result, but I get this result. Okay, good. So I know the resultant is OX, OY, and times something sum. I get some value. Now, is this R a vector or a scalar? We know OX is a vector, OY is a vector. So when I combine two vectors, when I add two vectors, the result is also a vector. So when I say the result is a vector, it has the value this one, but what about the direction? How is that vector placed? We should know that when two such vectors are given, the resultant vector will be somewhere between them in such a manner. If I complete the parallelogram here with these two vectors like that, then the diagonal represents the resultant of the vector, and it makes an angle alpha here, where alpha is given as tan inverse of OY sine of angle theta whole divided by OX plus OY cosine of the angle theta. So, this completely represents the sum of the two vectors. So, when I want to add two vectors, what I got to do is, I have to find the resultant, that is the sum of the two vectors, by this equation, and find what this vector makes with OX in terms of this one. Why should I find with respect to OX? Why not with respect to OY? Yes, I can find. And that angle is beta. Then beta is given as tan inverse OX sine of the angle theta over OY plus OX cosine of the angle theta. You can see in this equation and in this equation, it's very easy to memorize because sine theta, cosine theta are in the same places. The only thing is that OY and OX have switched places. So if you are finding alpha with respect to OX, then OX doesn't have any sine or cosine attached, whereas the opposite one is attached. Similarly, beta is the angle made with OY, so OY is here without any attachments, and OX has sine and cosine. That's how you remember that. So this is the resultant, sum of the two vectors, and its direction either this one or this one, whichever you want to prefer. So this is how you represent the sum of two vectors. So if R is a vector, then R bar is a vector. Let's say R bar is equal to here in this. Let me call this as R, point R. So R bar is OR bar. And OR bar has a magnitude, this R, and its direction either alpha or beta are given by these equations. So these OX and OY will now be called as the components of OR. So previous class we know we resolved a vector OA into its components here and here. Similarly, this OR vector will have its components OX and OY. So when you are adding two vectors, you get a result. So those two vectors are the components of the resultant vector. We'll continue our talk in the next class.